How are you, my friends? This is lecture number 3 from the Calculus 1 lectures, the limit concept. Now, the objectives of this lecture will be the idea of the limit laws, substitution of limits, slope predictor functions. Now, the limit of a function, it's a number L. We say L is the limit of the function as x approaches a, provided that we can make the number as close to L as we can by choosing x sufficiently near a number a, very close. We'll explain that in the examples. Limit in mathematical terms can be written as the limit of the function as x goes to a is equal to L. And we read it like this. We say the limit of f of x as x approaches or goes to a, the limit is L. Let's see an example here where we say investigate the value of the limit. In the example, we will explain the idea of the limit here. The limit of this function x minus 1 over x plus 2 as x goes to 3. Let's see. Now here we have 3. It's a number between 2 and 4. So we can come to 3 from the positive side, or we can come to 3 from the negative side. Let's approach 3 from the positive side. So we start here with 4, replace 4 as x value in the function, we will get 0.5. You can do that. And then take another point, 3.1. So we are going closer to 3. So the number will be 0.411, etc. Take another x, 3.01. Then take another point, 3.001. Then take another point, 3.0001. Then you can take as many numbers as you like closer to a. So this x here, this is the value. It will come closer to the a, 3. And then the limit here is become 0.4. Also, if you take any value from the left of 3, start with 2 here, it will be, the value will be 0.25. Take 2.9 more, 2.99, 2.999. If you come closer to 3 from the left side, so x will be 3 here, and then the value will be 0.4. So we can say that the limit of this function is 0.4, which is 2 over 5. Now, there are ways easier than this investigation. Let's take another example. Function f of x is equal x divided by absolute value of x. That's easy to graph, because here absolute value, we can take it one time positive, one time negative. Let's find the value of the limit of this function as x goes to 0. So we can draw the function now. The function is minus 1 in the negative, x less than 0, so that's a minus 1. The function is not defined at 0, so there is a hole here. There is another hole here. And then the function is 1, so this is a positive 1 constant on the right side. Let's see the limit. As x goes to 0, see x approaches 0 from the right side, we see the limit f of x goes to, this is goes to 1. And then if x goes to 0 from the left side, 0 negative here from the left side, then the function is becoming, the limit is minus 1. So here we say the limit does not exist, because the limit from the right not equal the limit from the left. So we say D and E, or the limit does not exist. Another easy example, we have function f, capital F here, it's just a function. 1 if x is not 0. The function is equal to 0 if x is equal to 0. Let's find the value of the limit of this function as x goes to 0. It's very important, very nice, easy way to look at the graph. So the function is 1, so it's all constant 1, except at 0, it is 0 here, point. Now let's take from the right side. If we are coming to 0 from the right side, we see the limit is 1. Also from the left side, the limit is 1. The limit, not the value. So we say the limit of the function as x goes to 0 is 1. Now here there are two notes, important notes. The limit from the right is equal to the limit from the left for this function. Now, the second point, the limit as at x as x approaches 0 is not equal to the image. You know the image? When we say the image, find f of 0. This is f of 0. The function value at 0. It is 0 here. So not always we have the value of the image is equal to the limit. Sometimes they are equal, sometimes they are not. Here we have 6 laws, the limit laws, so easy to see and apply. The constant law, we have constant times a function, we can take the constant out. Or if the whole function is constant, the limit of c, it's a number like 5 or 6 or 7 as x goes to a. Here we have some laws, you have seen that. The limit of a sum is the sum of the limits. The product law, this is a product. The quotient also, when we find the limit of a quotient, something divided by something. The power law, we have a function f to the power l, n. So the limit is l to the power n. Root law is nth root of f of x. It will be nth root of l. Remember, L is the limit of the function f, and capital M is the limit of the function g. Now let's start looking at example number 4. Find the limit of this function x squared plus 2x plus 4 as x goes to 3. So we can directly use the limit laws 2, 1, and 5. Let me show you what is 2, 1, and 5. 2, we start with the sum law, then the constant law, then the power law. So you can review that. So it will be the limit of x squared as x goes to 3, limit of 2x, limit of 4, this is a constant. So it will be x squared plus 2 times 3 plus 4, which is 19 is the limit. Another question, find the limit if it exists of this rational function, 2x plus 5 divided by x squared plus 2x plus 4. Also, we can use the limit laws 4, 2, 1, and 5. So the limit of this function divided by the limit of the second function, this is like f and g. If we replace 3 in the function, there is no 0 in the denominator. So the limit is 11 over 19. Substitution law of limits. If we have a composition f circle g, we need to find the limit of composition of two functions. F circle g of x will be the limit of f of g of x. The limit of the g is L, and the limit of f of x as x goes to L will be f of L. So this is what we call substitution. We substitute now the limit of g is L, and that will be f of L. Let's take an example here. Find the limit of cube root of inside, we have 3 square root of x cubed plus 20 square root of x. How can we find the limit of this as x goes to 4? We can take the big function here, the outside function, the cube root of x as a function f. So this is cube root of all this as x. The inside one is a g, 3 square root of x cubed plus 20 square root of x. This is the g function. So we can use the composition here. The limit of the composition is f of the limit of the g. So this is f here, the cube root of x. Limit of the inside, just substitute there. You will get 4 to the power 3 over 2. This is 2 squared. That will be 2 squared. 8 times 3, 24. And this is 2 times 20 is 40. And this is cube root of 64. The answer is 4 is the limit. Now, this is an important formula we call slope predictor function or formula. So it will be the limit of this function f of x plus h minus f of x divided by h. The limit as h goes to 0. So this will be the slope predictor function for the tangent line to the function y equals f of x. Now, m of x here, it's a function here. Later, we will see that this function here, m of x, is the derivative of this function. We can see that later in the lectures. Let's find the slope predictor function for this function, y equals f of x, ax squared plus bx plus c. That's a quadratic function. You can replace a by a number, b by a number, c by a number. Let's find the slope predictor function. So we start. This is the difference quotient. Remember this formula, we have seen it in the algebra course. This is the limit of f of x plus h. So I replace x plus h here in the function. So it becomes a x plus h squared plus b x plus h plus c minus the function itself, ax squared plus bx plus c, all divided by h. Just expand here, x squared plus 2xh plus h squared, multiply by a, multiply here bx, bh. Simplify everything, you take h as a common factor, you cancel it. You get the limit of this function now, 2ax plus ah plus b. As h goes to 0, see this is approaching 0, so now we have the slope predictor formula is 2ax plus b. Now you can go back to lecture 2 and see example 5a. Here, example 5a, to find the slope. 2ax, a is the coefficient of x squared, b is the coefficient of the x, and x is the value where we have the tangency point. Now, the 4 steps, I put it here in one slide, how to find the slope predictor function for any function. Write the definition of m of x, which is this one here. You see, this is definition. M of x is equal to that one. Always write it there, and then substitute in this m the given function, f. Simplify until step 4 can be carried out, which is find the limit as h goes to 0. Let's take another example here. Find the slope predictor function for this function, f of x 1 over x. You can go slowly here. Write the function for the slope predictor function, m of x, the formula. M of x is equal to the limit of, as h goes to 0, of this difference quotient. So the limit will be 1 over x plus h. Just take x plus h, replace it in the x, minus 1 over x. Now you can here subtract the fractions, find the LCD, x plus h times x. This will be x minus in the bracket. You have to put a bracket here, x plus h. So it will be x minus h. You cancel x. Now here we have to use division of two fractions, remember? A over b, c over d, you multiply by the reciprocal, 1 over h. Cancel the h, so we have the limit of minus 1 divided by x in the bracket, x plus h as h goes to 0. So when you simplify that, it will be minus 1 over x squared. This is the formula we use for the slope at any point for this function. Okay, now, all right. So you can check the playlist, Calculus 1 solved questions, for more questions other than the examples you see in the lecture, to learn more about finding different types of limits and slope predictor functions. Now, this is the end of lecture number 3. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.